at this point, we know what the mathematical model is used by finite element codes such as ANSYS to solve Truss problems. It's based on minimization of total potential energy, and we also saw how that minimization happens to generate algebraic equations relating neighboring pin displacements. I'm getting antsy to get into ANSYS. You probably are too. But there's one more thing we need to do before we get into ANSYS, and that is perform hand calculations of expected results and trends, which is very important. It's often overlooked, and it's a good idea to do it before you get into ANSYS. And the more we practice this, the more we are thinking like expert engineers. So let's do that. Here's the truss we have, and here are, the given parameters. So this is area, cross-sectional area, length, Young's modulus, and the magnitude of that external force that's applied on the truss. And from that, we can estimate what the order of magnitude of pin displacements is, and then when we look at the displacement answers, we can say, hey, do these displacements look the right order of magnitude? Let's do that. To make that hand calculation, to perform that hand calculation, I'll go back to something I discussed before, how you go from the axial displacement of a bar to its force, the force in the bar, and potential energy. Now in the hand calculation, we'll go in the opposite direction. We will estimate the force in bar AC, and from that we will go in this direction and get an estimate of what the axial displacement is going to be in bar AC, and from that we'll say, hey, the displacement of pin C is going to be of that order of magnitude. In FEA, keep in mind that you're always going from the displacement is your primary unknown. Displacements at the nodes, in this case the pins, and everything else is calculated from that. In hand calculations, often you're going in the opposite direction. Okay. That's a useful thing too. That's a useful thing to contrast. Okay, so I want to estimate the displacement at C. Okay, I just want to get an order of magnitude. So first I want to find the force in bar AC. So I'm going in this direction, and I'm looking at bar AC. The force in bar AC is going to be of the order of magnitude of this force. In fact, it's going to be higher, right? Because the component of this force in this direction has to balance that. But I'll just ignore that. I'm just trying to get an order of magnitude. So that's actually 1200 newtons. And then I have to divide that by the area. So if I take the force and divide it by the area, I'll get the stress, and the area is 0.81, and it's centimeters squared. So I'll multiply that by 10 to the power of minus 4 to get to convert it to meters squared. And then so I have the stress now, and if I divide that by the Young's modulus, I will get the strain. So the Young's modulus is 200 gigapascals, so 10 to the power of 9 in pascals. I'm calculating everything in SI units. And that gives me the strain, and then if I multiply the strain by L, I will get the displacement. So, and L is going to be, root 2 times this length, because this is a hypotenuse. So this is L is 45. So this is going to be of the order of 1.4 times that, which I'll say is it's about 40% higher. So I'll just say it's 65. Again, I'm not looking for exact numbers here. Oh, that should be minus 2. Okay. And then I can, so this is going to be, so this 10 to the power of minus 4 times 10 to the power of 9 is of the order, is 10 to the power of 5. And if I bring that up, I'll get 10 to the power of minus 7. And then I can, in fact, what I'll do is I'll switch colors, so I can cancel that. I'm just trying to get an order of magnitude. So this is about 6, this is 6, and then if I multiply 6 by 0.8, that'll give me of the order of 8. 65 times 10 would be 650, so 65 times 8 would be about 500. So I'll say this is 500 of the order, or of the order of 5 into 10 to the power of minus 5 meters. Very small displacement, so we shouldn't be surprised if we see very small displacements in answers. So that's the order of magnitude for the displacements that we will be expecting from answers. And then we can also calculate the reactions at A and B, because this is a statically determinate truss. So you write a force balance in the x direction and the y direction, and then a moment balance, and you'll get the reactions. I'll let you calculate that. And then from the reactions, if you do a force balance at pin C, once you know this reaction, you can figure out what the force is and these bars are, and then you can do a force balance at pin A. Knowing the reactions, you can figure out what the force is in AC. So you can get the forces in the bars. Again, I'll let you do that. Okay. At this point, we have done a satisfactory pre-analysis, and we are really ready to get into answers. So let's do that.